All right, let me explain this real quick because this demo is pretty epic. So what do we have? We have a STM32. You can see it's running some firmware here, so the LED is turning on and off. So it's running my firmware, and basically that's fine. This firmware actually sets the security, so it sets everything to RDP2. Here I have a cheap Chinese FPGA, and I'm driving, so I'm feeding the power to this socket, which is running the STM32. I mean, we can take a look at the STM32. It's inside of there. So it's feeding the power to the socket from the GPIO of the FPGA, which isn't great, but this is a cheap FPGA, so I don't care if it dies. Then I got a J-Link debugger here backing me up and letting me do everything with that related to talking to the JTAG / SWD on here. I have a reset pin, which I can touch to ground to get that going. And then I also have a UART connected here, and I'm going to be running that on the scope. And so we should see data on the scope when the exploit actually works. What I'm actually going to be doing, there's a bug in the Cortex-M3 core, and what it's allowing me to do is to set a breakpoint to address 0, which is where flash loads from. However, on the STM32, they also have the possibility that you can boot from RAM, and that's what we're going to be abusing. From a hardware point of view, you shouldn't be able to boot from RAM and then reboot from flash. I mean, you shouldn't be able to load something in a RAM and boot straight from it. That's something that I assume they reserve for themselves for doing at the factory. However, we can do it by writing using the J-Link. We can write to the STM32, and then using the FPGA, we can power cycle really quickly without losing the data. So essentially, we'll have a cold boot attack that will let us get into the system. So here's the steps. We're going to run J-Link exe on here to load everything in a RAM. So I'm going to do load file. And then I'm going to click, I'm going to select the shell code. So this code is going to essentially overwrite the breakpoint, which means that we can remap what the contents of SRAM into flash, thanks to the breakpoint, because the breakpoint's going to execute there. And that's what's going to give it us code execution on the STM32. So here we go. I'm going to do con. We're going to hit enter, 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 enter. So now what we can do is load file. Let's load the shellcode again. There we go. Okay, and so now let's try rebooting because we have to execute the shellcode first. I'm going to reboot. This time when I reboot, the LED shouldn't turn on. Right now the LED is off because there's a fault handler to prevent you from connecting with the debugger. So hit R. I'm checking the LED. LED is not on, so it's potentially executing our code. And now what I'm going to do is after it runs through the code once, we can basically do a reset so that it executes that code again. Okay, and now what I'm going to do is I'm going to try to boot from flash. However, since we're retaining the state, the breakpoint will be set, and so instead of actually executing flash, it's going to execute our shellcode, and so we should see something on the scope. So let's get the scope configured. All right, so that worked, and you can actually see, we can zoom in and take a look at what's happening on the scope. And so here, if you zoom in, you can see it says low level shell. So I mean, it's actually executing my code here. So we got code execution through the breakpoint, through the possibility of the STM32 letting you execute from RAM.